Hello, my dear students. Welcome to BYJU'S Exam Prep, the most comprehensive preparation app for GATE and ESE. So today we'll be having the concept through questions for BARC 2023 and one of the very important and favorite subject, that is theory of machine. So very good evening, all of you. Good evening. I hope everything is good with audio and video. All good, all perfect. Okay. So today, let's start the session. Good evening. Good evening. No one. What's your name? No one. So how's your BARC preparation going on? I hope everything is good, perfect, and I think on daily basis you are having the practice session. So it's hardly a matter of like 40-45 minutes and you'll be able to practice almost every question from the entire syllabus, or at least 90% of the syllabus we are covering. Okay, fine. So let's start the session and let's have a quick discussion about the topics of theory of machine, right? And it's also why I'm saying this is an important segment, because almost this is not a previous year gate. We'll be taking some new questions which is basically not previous year gate, but definitely the level of question is slight, we can say, at par more than that of gate. Okay, सर मॉक होगा, बिल्कुल होगा, यस सौरभ, डेफिनेटली मॉक होगा, राइट? ठीक है, सो डोंट वरी अबाउट दैट. Fine. चलिए, so let's, because first of all we'll be going for the almost complete discussion of the practice session individual subject wise, and once we are done with that, then we'll be proceeding with the mock test. Okay, fine. So I hope everyone has connected with me on the Telegram channel. If not yet connected, you can connect with me on my Telegram channel, that is your Mechanical by Suraj Gopi. Okay, fine. Good evening, and very important, those who are planning to give GATE next year, right? So there's a scholarship test which will be having up to 90% will be given, right? So it's a best thing, and you can ration it now, and the exam will be scheduled from 2nd of April. Okay, so I think everything is good, all perfect. Yeah, 1 second. Yes. Okay, apart from this, 4th April, Dheeraj sir and Ashutosh sir will be coming live on 4th April, 7:30 p.m. and they'll be helping you out for all the 2024 aspirants. But for this session, I would rather say let's get ready for the BARC. Let's get ready for the BARC and let's see how much you have prepared for this BARC examination. Let's see how much you'll be able to give your best. Take out your calculator, a piece of paper, a pen, and let's start with the first question on your screen. Okay, there's a question: a wheel of radius 300 mm rolls to right side without slipping and has a velocity of the center of mass as 3 meters per second. The velocity of point A at distance 200 mm from the center, that is O, on the wheel for the instant shown below will be. So you have to calculate what is the velocity of point A. What is the velocity of point A, which is at a distance of 200 mm from the center and at an angle of 30 degree. And OA distance is given as 200 mm. And the velocity, the translational velocity, is given as 3 meters per second. Okay, Saurav, Kiran, good evening. Let's see who will be giving that. It's a very easy problem. It's a question from the your rolling motion, right? Now we know that whenever there's a pure rolling motion, that means rolling without slip, the instantaneous center will be located at the point of contact. Let's say this is I. If I want to calculate the velocity at any point on the roller, what you have to do, you have to just measure that point from the instantaneous center, right? So if I say this is point O, this is point A, right? This is point A, right? Or let me do one thing. Let me take the next slide because that will be helping out. Yeah. Okay. So this is point I, that is the instantaneous center. Let us join these 2 points. Okay. So if I try to calculate, that means it is framing a very simple a triangle like this. This is O, this is A, this is I. So definitely this angle will be, what will be this angle? This angle 90 plus 30 is 120 degree. 120 degree, right? So you can get the value of AI. AO is 200 mm already given. IO, what is IO? That is nothing but the radius, which is given as 300 mm, right? 300 mm, right? So you can calculate the value of AI by using the cosine rule. AI square is equal to OA square plus OI square plus minus 2 into OA into OI into cos of 120 degree. So from here you will be getting the value of AI is equal to, what's the value of AI you are getting? The distance AI. Because once you get this value, because whatever will be the angular velocity, let us say this is omega, right? So we can say the velocity at point A will be equal to AI into omega, right? What is the distance? OA is given 200, OI is given 300. You can use this formulation and you can get the value of AI. Are we getting this value as 435? 435.88. Very good, Kiran. 435.88 mm. So once we are getting this value, but the problem over here is they are not giving the value of angular velocity. They are not giving the value of omega. Very good, Rishi. Rishi have responded one answer. Let's see whether it's correct or not. The problem is they have not given the value of omega. How we can calculate this? How we can calculate this omega value? We know that for pure rolling motion, V0 is equal to R into omega. Yes, V0 is equal to R into omega, right? So can we say omega is equal to V0 by R? Okay, so I can just place it over here. So velocity at point A is equal to AI into your omega. So I can say AI into, what is omega? That is V0 by R. So this is AI is 435.88 into V0 is 3. Radius is how much? Radius is 300 mm. Okay, so you'll be getting approximately 4.35 meter per second. I think option B is the correct answer. 38. How you're getting option A? How you're getting option A? This direct straightforward. And if you're doing a slight mistake, you'll be getting the wrong answer. If you're doing one calculation mistake, if you're placing the wrong values, you'll be getting the wrong value, wrong answer, and that is also available in the option. That is option A. Is this clear? Okay, fine. Understood? So in this case, option B is the correct answer, 4.36 meter per second. Exactly. Basically, it will be 4.3588. So you can round off to 4.36 meter per second, right? So option B is the correct answer, not A. Okay, fine, because I think Rishi, Saurabh, Kiran, in one stretch, they have given me option A, which is not correct. Option B is the correct answer. Clear? Fine. Chalo, next question on your screen is from the very interesting topic, that is gear train. Okay, an epicyclic gear train has 3 shafts A, B, and C. A is the input. Okay, so we are having 3 shafts. This is your A, right? We are having B, and we are having C, right? A is your input running at 50 RPM in the anti-clockwise direction. So that is omega A is equal to minus 50, or let us say NA is equal to minus 50. I'm taking negative as anti-clockwise. Okay, RPM. Fine. C is the output shaft running at 200 RPM clockwise. So NC is equal to 200 RPM in the clockwise direction. The torque A is having 100 kilonewton meter in clockwise direction. So TA is equal to 100 kilonewton meter. B is fixed. Okay, B is fixed. So they are saying what is the torque needed to fix the shaft B? What is the torque needed to fix the shaft? And they're not giving any efficiency. You can take it as 100% efficiency. There is no losses. Okay, if we have given the efficiency, then you have to consider the losses. But as they have not given, so you can take it as there is no losses. All the energy, we can say, all conversion is happening. There is no power loss. Fine. Kiran has given me the answer. Perfect. Anyone else? Okay, so we can apply the simple logic that your total torque will always be constant. TA plus TB plus TC should always be constant. So that will be having a 0 value. Okay, that will always be having a 0 value, right? And the second thing is TA into NA plus TB into NB is equal to 0, right? So from here I can get the value of TB. TA is equal to 100. This is 100 into NA is minus 50 plus TB into what is NB? NB, they are, okay, this is your, this will be C, right? This is input and output. This should be C, because B is the fixing torque. Okay, TC we need to calculate. NC value is 200. So from here I can get the value of TC is equal to, this will be how much? 5000 by this. So it will be 250. Yes. Or 25, not 250. 25 kilonewton meter. Yes. 25 kilonewton meter. So once I'm getting value of TC, I know the value of TA, that is 100. I can write it as TA plus TB plus TC equal to 0. TA is 100 plus TB, that fixing torque we need to calculate. This is 25 equal to 0. So TB is equal to minus 125 kilonewton meter. The meaning of this is your fixing torque will be having the direction of anti-clockwise. So option D, 125 kilonewton meter in the anti-clockwise is the correct answer. Option B, D is the correct answer. Very good. Kiran, Rishi, absolutely correct. Saurav, is this clear? No one? Done? Option D, 125 kilonewton anti-clockwise, because I'm assuming anti-clockwise direction as negative and clockwise as positive. So definitely you'll be getting option D is the correct answer. Chalo, next question on your screen. There's a question from the flywheel. The turning moment curve for an engine is represented by the equation T is equal to 2000 plus 950 sine 2 theta minus 570 cos 2 theta, where theta is the angle turned by the crank from the inner dead center. If the resisting torque is constant, the angular acceleration of the wheel when the crank has turned by 45 degree from the inner dead center. Take the moment of inertia as 320 kg meter square. Easy question, very easy. Very easy. Okay, let's see who will be giving me the answer. Easy question. Yes. So without solving, can we say what is the mean torque? Without solving, can we say what will be the mean torque? I can simply say this is the actual torque. I can say mean torque will be simply is equal to 2000 Newton meter. Yes. And tell me, this angular acceleration will be the flywheel will be accelerating when the flywheel is releasing the energy or storing the energy. The flywheel is gonna accelerate when the flywheel is absorbing the energy, right, or storing the energy. Then only there will be an acceleration. So can we calculate what is the excess amount of torque that we are having? Okay. What is the T excess value? T excess will be equal to T minus T mean. So this will be equal to your 2000 plus 950 sine 2 theta minus 570 cos 2 theta minus 2000. So from here I'm getting the value as 950 sine 2 theta minus 570 cos of 2 theta, right? Okay, fine. Now they are saying that what is the angular acceleration of the flywheel when it has turned 45 degree from the inner dead center. That means at theta equal to 45 degree, can we calculate what is the excess torque that we are having? The excess torque will be equal to sine 90 will be 1. This will be 950 cos 90 is 0. So 950 Newton meter. Okay, and that is also equal to, because if you're having a torque being applied, so that will be equal to I into alpha. So from here I can get the value of alpha as simply as 950 divided by moment of inertia that we are given is 320. So can you tell me what's the answer you're getting? 950 by 320. Okay, Rishi saying option C, 2.97. Anyone else? Are we getting 2.97 radian per second square? So we'll be getting exactly 2.97, I think. 2.97 radian per second square will be the correct answer. Let us cross check. 950 divided by 320. 2.968. Precisely 2.968. So round off, we can say 2.97 radian per second square. Okay, fine. Option C is the correct answer. Clear? Perfect. Chalo, next question on your screen. Easy है तो बहुत easy question है. चलो next question. Okay, from the velocity analysis and without velocity analysis our practice is not complete, right? Okay, fine. The horizontal motion of the piston rod of the hydraulic cylinder controls the rotation of the link OB For the instant represented, VA is equal to 2 meter per second and OB is horizontal. The angular velocity, it's not infinity, the angular velocity of OB at this instant is, what is the angular velocity of this link OB, and it is rotating in an anti-clockwise direction. That means it is trying to rotate like this. Let's say this is omega. So we need to calculate the value of this omega OB. How to proceed? Simple question. Apply very simple logic. Apply a simple logic. Now, if I say there's a this point A and B is basically located on the link AB, and if this is rotating with an angular velocity of omega like this, so definitely its velocity will be in direction vertically downward. Let's say this is VB, right? And where you will be having the instantaneous center? The instantaneous center of this link AB will be simply intersection point from the perpendicular drawn over here. So this will be the instantaneous center. Okay, fine. If I got the value of instantaneous center, I can get the value of VB. If VB is calculated, because VB is equal to OB into omega OB. OB value we know, right? Omega OB, we have to calculate. VB we need to calculate. And how we can calculate the value of VB? By simply taking the velocity, doing the analysis of velocity. Instantaneous center we know. Okay, fine. So we can say VA is equal to your AI into omega AB, and VB is equal to BI into omega AB, right? Or I can say VA by AI is equal to VB by BI, right? What is VA? That is 2. What is AI given? That is 160. That is already been given. Okay, but we need to calculate the distance of BI. Can you tell me what will be the distance of BI? This is a right triangle. Okay, hypotenuse height is 160, hypotenuse 180. So this is your B, this is your I, this is A. I can get the value of BI is equal to root of 180 square minus 160 square. This will be somewhere around, yes, what's the value of BI? 180 square minus 160 square. Root of this will be getting 82.46 mm, right? So that is equal to VB by 82.46. Okay, fine, perfect, very good, Saurav. So from here I can get the value of VB. VB is equal to how much? 2 into answer divided by 160, 1.03. 1.031 meter per second. So I got the value of VB. So once I'm getting the value of VB, you can use this relation. I can get the value of omega, angular velocity of OB, right? So I can simply say VB is equal to, and this will be, I think, mm per second. Okay. This is meter per second, not mm per second. Meter per second, yeah. VB is equal to OB into omega OB. So omega OB is equal to 1.031. OB is distance has 0.12. So what's the value you're giving? 8.58. 8.5898 radian per second. And the option that is matching with is option C is the correct answer. Option C is the correct answer. 8.588 or 8.59 radian per second will be the angular velocity of this particular link OB, right? Okay, fine. 8.59 is the correct answer. Very good. Option C is the correct answer. Done? Clear? Fine. Chalo, let's go and let's talk about some questions from the vibration topic. Okay, a 45 kg piston is supported by a spring of modulus K is equal to 35 kilonewton per meter. A dashboard of damping coefficient 1250 Newton second per meter acts parallelly with the help with the spring. A fluctuating pressure of 4000 sine 30 Pascal acts on the piston as shown in the figure below, whose top surface area is 50 into 10 to the power minus 3 meter square. what will be the magnitude of the steady state amplitude of vibration? So they have given you the value of mass that is equal to 45 kg, right? They have given you the value of K that is equal to 35 into 10 to the power 3 Newton per meter. They have given the value of coefficient of damping that is 1250 Newton second per meter. Okay. And they're asking you what will be the value of amplitude. There's a simple formulation. Yes, there's a simple formulation to calculate the value of amplitude. What's the formulation? For that, I need to cross verify whether there is an under damped or damped. Okay. Whether this is under damped and over damped or critically damped. Because if this is a critically damped or over damped, you won't be having any vibration. So amplitude will be 0. You won't be having any vibration, right? Okay. So for that, let us first of all calculate the value of zeta. What is the value of zeta? Zeta is equal to C by 2 root K into M. So C value is 1250 divided by 2 into K value is 35 into 10 to the power 3 into mass is 45. Can you tell me what's the value of zeta? Are we getting an over damped or under damped or critically damped? Is this zeta value less than 1 or greater than 1 or equal to 1? Yes. You'll be getting somewhere around, let us calculate 3 by 1, 2, 3 into 45 into 2. 0.498. 0.498. Yes. So that means we are talking about under damped system. And if you are talking about under damped system, the vibration will be present. Vibration will always be present. So I can say this: the amplitude is equal to F naught by K divided by under root of 1 minus omega by omega n whole square plus 2 zeta omega by omega n whole square. Okay, for that I need to calculate the of omega n. Now omega n we can directly calculate it as omega n is equal to under root of K by M. Okay, K value is 35 into 10 to the power 3, mass is 45, root of this, you'll be getting the value of omega n, you'll be getting some value, right? Okay, fine. Now the question is, what will be the value of omega? You can clearly see the expression that they have given. So omega is nothing but is equal to 30 radian per second. By comparing this equation with over here, the omega is equal to 30 radian per second, right? But the problem is they have not given the value of F naught. This is the pressure they are talking about. So how we can calculate the static pressure? Oh, static force. How we can calculate the value of F naught? Can we say F naught is equal to pressure into area, right? Pressure is given as 4000 and they have given the value of area as 50 into 10 to the power minus 3. This much of Newton of force will be acting on the this particular mass which is having a 45 kg. Yes. So now let us place all these values over here. So F naught is 4000 into 50 into 10 to the power minus 3 divided by K value is 335 into 10 to the power 3 divided by under root of 1 minus omega is your 30. What is omega n? Have you calculated the value of omega n? This will be, I think, 27.9 radian per second. Yes. Are we getting this value? Yes. Okay. So now let's calculate and get the value of amplitude of vibration. Okay. Fine. Chalo, let's see. 35 divided by 45. 27.88. Yeah. 27.88 whole square plus 2 zeta. Zeta value that we have already calculated as 0.48 into 30 divided by 27.88. So here we are talking about a case where omega is more than that of omega n. Omega is more than that of omega n, right? So don't be having any changes because this is whole square. So we'll be getting some value, right? So try to calculate and tell me, and try to calculate in mm only. They are saying round off to 2 decimal and you have to tell me the answer in mm. Okay, So if you try to calculate, it will be coming near about to 5.28 mm. Please check everyone. Near about to 5 point. Very good, no one. I think option A, 5.28 mm will be the nearest, closest answer, approximate answer that you'll be getting. 5.31, perfect, perfect. That means the nearest answer is option A. Okay, fine. So here, usually in the examination, they are giving the value of F naught directly, but they have given the value of pressure. So you have to first of all calculate the value of the force by converting that pressure into force by multiplying with the area which they have given, the top area that they have given. Okay, fine, right? So that was the only new thing that usually they are not giving like this. They are directly giving the value of F naught. So we have just taken up an example where they have indirectly given the value of force. Okay, option A, very good. Is everyone getting 5.28? Slightly calculative, I know, but yes, if the question is coming in the bar examination like this, so you have to be ready with that. Okay, fine. Let's go with some question from the gyroscopic topic. An aeroplane is flying at 90 meter per second, which is turning towards right and completes a quarter circle of 50-meter radius. The mass of the rotary engine and the propeller of the plane is 400 kg with the radius of gyration is 400 mm. The engine speed is 250 radian per second anti-clockwise when you viewing from the nose end, that is front end. Okay, that means we are having this aircraft, something like this. Okay, and you are viewing from the front end, right? If I'm assuming that you are viewing from the back end, that means this engine will be rotating with a clockwise direction. Yes, we can just reverse according to our suitability. So omega they have given as 250 radian per second. Omega p we can calculate, that is V by R, 90 divided by 50, that is equal to 1.8 radian per second. I is equal to mk square. Mass is 400, this is 0.4 square, you can get the value of I. So from here you can first of all calculate the value of gyroscopic couple, that is C, that is equal to I omega p. So two options will be directly being eliminated, right? Either it will be A or B or C or D, in between this only, right? So you'll be, when you place this, you'll be getting this, this is kg meter square. You'll be getting this value to be 28.8 kilonewton meter. Yes, 28.8. So we can directly eliminate option C and D directly. So now the question is, what will be the effect? Because definitely if the magnitude was unique, you can just calculate the magnitude and you can get that. But here they have given you that the gyroscopic effect also. Okay, so there's a simple technique. I think we have already studied this kind of technique. If I say this is the front end, this is the rear end, right? It is rotating clockwise from the rear end. So turn your finger like this. Now the aeroplane is turning towards right. So if the aeroplane is turning towards right, this will be your active gyroscopic effect. So opposite will be the reactive. So the front portion will try to move downward. This will be the gyroscopic effect. That means option A, the front side will be going in the downward. That is the gyroscopic effect that will be getting. Okay, option A, option A. Option B is the active gyroscopic couple, right? Okay, we will never ever, we always take the reaction. We always take the reaction. We never take the active gyroscopic. We always take the reaction of that. Okay, it's a simple technique. Always try to see the aeroplane from the back side. It is rotating clockwise from the rear end and you're turning the aeroplane towards right. So the thumb will be pointing towards the screen. This is active. Reactive will be opposite of this. Turn your finger. The front portion will try to move downward. That is your gyroscopic effect in this particular problem. Okay, fine, clear. Okay, chalo, let's proceed to the next problem quickly. Question, is this clear everyone? Are you able to get this answer? Magnitude is very easy, you can calculate in a fraction of second, but direction is important. Okay, fine, chaliye. Rishi, is this clear? Because you were responding option B and I think this should be perfect. Question number 7. A dynamic system represented by this is 3x double dot x dot and 27x equal to 0. Damped free vibration in radian per. That means they're asking you what is the value of omega d. What is the value of omega d? Very easy question. They have given the expression, that is 3x double dot plus 10x dot plus 27x equal to 0. So we can just compare this with our standard equation, that is mx double dot. You can compare with the standard equation mx double dot plus cx dot plus kx equal to 0. So m is equal to 3, c equal to 10, k equal to 27. Apply and get the value of this. So zeta is equal to c by 2 root k into m. C is 10 to k is 27 into 3. So this will be 9 into 3. This will be your 81 9. So this will be 10 by 5 by 9. 5 by 9 will be the zeta value. Perfect. Perfect, Saurabh. Okay, so now we can get the value. So we can say omega d is equal to under root of 1 minus zeta square into omega n, right? So for that, I need to calculate the omega n, that is equal to root of k by m. K value is 27 by 3. So that is your 3 radian per second. Okay, so if this is 3 radian per second, so omega d will be less than that of omega n, right? So you can eliminate option D, C and B. Option A is the correct answer. Even if you don't want to solve it, you can apply the simple logic. The damped vibration will always be less than that of the natural frequency of vibration, right? So if you try to apply that logic, you are getting option A, but still we'll be solving this completely. Okay, 1 minus zeta is 5 by 9 whole square root of this into 3. So from here I'm getting this exactly 2.49 radian per second. Right? Okay. Sometimes smart work is very important. Rather than doing calculation, you can apply the logic and you can eliminate the options and you get the answer. Okay, chalo, question number 8 on your screen is this from the topic of, again, vibration. Okay. An undamped foundation transmits 1/4 of the applied force. What is the ratio of the applied force frequency to the undamped natural frequency vibration? That means they're asking you what is the value of omega by omega, and this ratio they're asking, and they've given you the value of the transmitted force by the applied force, that is 1/4. Okay, chalo, let's see who will be giving the answer. What is this ratio called? The transmitted force divided by the applied or external force or unbalanced force. What do we call this ratio? Anyone? We have studied this in the force vibration, I think. Anna? Force vibration, we have studied this in detail. This ratio we call it as transmissibility. Yes. No, it won't be magnification factor. Transmissibility ratio. E. Ft by Fo. Yes, magnification factor is something different. Okay, that is the ratio of your we can say amplitude divided by the static deflection, or F naught by K. Fine, is this clear? So Ft by Fo they have given, but here they have not mentioned anything about the zeta. How we can get that zeta value? The zeta value they have not, because we know that E is equal to Ft by Fo, that is equal to under root of 1 plus 2 zeta omega by omega n whole square upon under root of 1 minus omega by omega n whole square plus 2 zeta omega by omega n whole square, right? If you read the statement carefully, they have said that undamped foundation. What's the meaning of this? Undamped means your zeta is directly equal to 0. If zeta equal to 0, our equation is reduced to a very simpler format. Okay, that is E is equal to Ft by Fo, that is 1 by 4, that is equal to 1 upon under root of 1 minus omega by omega n whole square, right? Okay, fine. So I can say this will be equal to 1 by 4. Now, as this is less than 1, so I need to just reverse this equation, that is omega by omega n whole square minus 1. Okay. Already I've responded, Philip. You have just messaged me in the Telegram channel. I think we have responded there also. Again, I'm saying NIT Warangal is far more having a higher, we can say, from design perspective. Warangal will be definitely a first preference in that of Surathkal. Okay. So just rearrange. You will be getting omega by omega n whole square minus 1, that is equal to 4. So omega by omega n is equal to root 5. So somewhere around 2 point something. Option B is the correct answer. 2.23. 2.23. Okay. Omega by omega n value will be simply equal to 2.23. Clear? Correct, Roshan. Very good. Fine. Next question. Question number 9 on your screen. Second last question. I need everyone to respond. A question from the riveting machine. A 3 kilowatt riveting machine takes 1.5 seconds to complete one riveting operation and it absorbs 12 kilonewton meter of energy. The moving part includes a flywheel which is equivalent to 220 kg at a 4.5 meter radius. If the flywheel speed is 360 rpm before riveting, then what is the speed of the flywheel immediately after riveting? If I'm assuming that omega 1 is equal to 360 rpm, okay, or I can say n1 is 360 rpm, then what is the value of n2? This is the question. Apply the logic of flywheel. It's a very easy thing. For completing one, we can say riveting operation, it requires 12 energy required will be equal to or even is equal to 12,000 Newton meter or joule of energy. Okay, 12,000 joule of energy, right? But the energy supplied by motor, okay, in 1.5 second, because it is having 3 kilowatt, that means 3000 joule per second of energy is being supplied every second. So I can say 3000 into 1.5, so this will be 4500 joule of energy is being supplied by the motor, right? Total I require 12,000 joule of energy, but the motor is only supplying the 4500 joule of energy. So where will be the rest amount of energy will be supplied? That excessive, that the we can say the leftover energy that is being left out, that will be supplied by the flywheel. So I can simply say delta E is equal to 12,000 minus 4500. So from here I can get the value of, I can simply get the value of your delta E. And we know that what is delta E? Delta E is also equal to the change in kinetic energy, that is half into I into omega 1 square minus omega 2 square. Okay, so before riveting we'll be having a higher RPM, after riveting we'll be having lesser RPM. So you can get the value of omega 1. Omega 1 is equal to 2 pi into 360 by 60, right? So this will be 12 pi radian per second, right? This will be 12 pi radian per second. Okay, so I can simply say what will be this 12,000 minus 45, this will be 7,500. Yes, 7,500 joule of energy is being supplied by the flywheel. So I can say 7500 is equal to 1 by 2. Now they have given some value of the equivalent mass and the radius. Okay, so you can say mr square, so 220 into 0.5 square into 12 pi whole square minus omega 2 square. So from here I can get the value of omega 2. Quickly tell me what is the value of omega 2 that we are getting. 300. Okay, you're getting 300. Option D, 324. Very good. Saurabh, correct. Yes. What's the value of omega 2? Are we getting this value to be 33.89 radian per second? That means just after riveting, its RPM will be reduced to this one. So I can say N2 is equal to omega 2 into 60 by 2 pi. Okay, so from here, if I try to calculate, this will be 33.89 into 60 divided by 2 pi. 323, 323.6 RPM is the final answer. So we can round off to 324. Option D is the correct answer. Option D is the correct answer. Is this clear? A simple question from the riveting topic. Basically, the concept of flywheel we have used over here. Okay, chalo, last question. Then we are good to go. A rod vibrates with a frequency of 2 Hertz when there is no damping. If damping is provided, the frequency of the damped vibration is observed to be 1 Hertz. What is the value of logarithmic decrement? That means your FD is equal to 1 Hertz and Fn is equal to 2 Hertz, right? So they're asking what's the value of delta? What is the value of delta? Chalo. So if I know the value of Fd and Fn, can I get the value of omega d? Omega d will be equal to your 2 pi. This will be, yes, everyone, 2 pi into Fd, that is 2 pi radian per second. And what is omega n? That is 2 pi into Fn, that is 4 pi radian per second. So I got the value of omega d and omega n. And we know that there is one relation. Omega d is equal to under root of 1 minus zeta square into omega n. Right? So from here I can get the value of zeta. Once I'm getting the value of zeta, I can use this delta is equal to 2 pi zeta divided by under root of 1 minus zeta square. Quickly, what's the value of zeta you're getting? Omega n is 4 pi radian per second. Omega d is 2 pi radian per second. We have to convert this hertz into radian per second. Very important. If you're directly using, you won't be getting the correct answer. Chalo. Zeta value. Omega d by omega n whole square, or you can say 1 minus this value. So we'll be getting the zeta value as point, yes, quickly. 0.866. Very good. 0.866. Place this value of 0.866 over here. You will be getting the value of delta as, very good, 10.88. 10.88. That means x0 by x1 is equal to e to the power delta. That is, if they are asking the consecutive ratio, then you have to take the x e to the power 10.88, which should be very high value. Okay, we should be having a very high value, but definitely we can just apply this over here, right? Fine. But here they are only asking you about what? They are only asking about the delta value, that is logarithmic decrement. So you can get the value of delta, that is 10.88. So from here we have concluded the 10 questions from our theory of machine topic. Okay, fine. So this completes your discussion for today's session. I'll be uploading this PDF just after the session on our Telegram channel, right? You can download, you can save it for your reference, for future reference, but I think that is not even necessary because you already solved almost all the questions very accurately. Some 1 or 2 mistakes happened. I think you have already rectified your mistake. That is very important. While doing the practice is very important, how you are recalling the mistakes, that is very, very important. Okay, so thank you guys for joining with me. I hope you all enjoyed. So let's try to wind up the session and try to be connected with BYJU'S Exam Prep, because every day almost you're having the practice session on this channel. Okay, thank you guys. Stay connected, stay safe, and enjoy your preparation with our BYJU'S Exam Prep. Thank you. Bye bye. Take care.